everyone. In this tutorial, I will complete solving part 3 of the ministerial question of lesson 4.3. We reach question number 52. Find the value of the limit when x approaches to positive infinity for the function 2x minus 1 over square root 2x power 2 plus 1 equal to limit x approach to positive infinity factorized by x for the numerator 2 minus 1 over x for the denominator under square root factorized by x power 2 2 plus 1 over x power 2 equal to limit x approach to positive infinity x 2 minus 1 over x over square root x power 2 times square root 2 plus 1 over x power 2. Separate the square root equal to limit x approach to positive infinity for x 2 minus 1 over x over, since x approach to positive infinity, then square root x power 2 equal to x. If x approach to negative infinity, then square root x power 2 is negative x. X over square root 2 minus plus 1 over x power 2. Reduce x with x, substitute every x with positive infinity, 2 minus 1 over infinity over square root 2 plus 1 over infinity square infinity equal to 1 over infinity is 0, 2 minus 0, 2, 2 plus 1 over infinity 0 square root 2 equal to, rewrite 2 as square root 2 times square root 2 over square root 2. Reduce square root 2 over square root 2. The answer is square root 2. Choice B. Question number 53. Find the value of the limit x approach to positive infinity for square root 4x power 2 minus 1 over 9x power 2 plus 1 equal to limit x approach to positive infinity 4 factorized by x power 2, 4 minus 1 over x power 2 over square root factorized also by x power 2, 9 plus 1 over x power 2 equal to, since x approach to positive infinity, then x power square root x power 2 equal to x. It will be limit x times square root 4 minus 1 over x power 2 over x square root 9 plus 1 over x power 2. Reduce x with x, substitute every x with positive infinity, 1 over positive infinity square 0, then the answer will be square root 4 over 9 plus 1 over infinity square also 0, 9 plus 0, 9 square root 9 equal to square root 4 2, square root 9 3. The answer is 2 over 3. Choice A. Question number 54. Find the value of the limit x approach to positive infinity for sine 2x minus x over 2x plus 1 equal to limit x approach to positive infinity for factorized by x for the numerator sine 2x over x minus 1 over, also for the denominator factorized by x, 2 plus 1 over x. Reduce x with x. Limit sine 2x over x by squeeze theorem is 0. Then the answer will be 0 minus 1 over 2 plus 1 over infinity 0, 2 plus 0. The answer will be negative 1 over 2. Choice D. How we know that sine 2x over x when x approaches to positive infinity is 0? By squeeze theorem, sine 2x greater than or equal negative 1, less than or equal 1. Divide all parts by x. Take the limit when x approaches to positive infinity, negative 1 over x is 0. Also, 1 over x, the limit when x approach to positive infinity is 0, then the limit for sine 2x over x when x approach to positive infinity is 0. Question number 55, find the value of this limit equal to limit x approach to positive infinity factorized by x, 3 minus 2 over x, over also for the denominator factorized by x, 6 plus cosine x over x. Reduce x with x, 2 over infinity 0, 3 minus 0 for the numerator over 6 plus cosine x over x when x approach to positive infinity is 0 by squeeze theorem also, the same steps, then the answer will be 3 over 6, 1 over 2. Choice B. Question number 56, find the value of the limit x approach to negative infinity for 3x minus 2 over absolute value 1 minus x equal to limit x approach to negative infinity for 3x minus 2, rewrite absolute value 1 minus x as negative 1 plus x when x greater than or equal 1, 1 minus x when x less than 1. Since x approach to negative infinity, then x is less than 1, then absolute value 1 minus x equal to 1 minus x equal to, since the degree of the numerator and denominator are equal, the answer is the coefficient of the leading term and the numerator, 3, over the coefficient of the leading term in the denominator, negative 1, equal to negative 3. Choice B. Question number 57, determine the equation of the horizontal asymptote to the graph of the function f of x equal to x power 2 over x power 2 plus 1 minus 1. Rewrite this function as f of x equal to 2x power 2, the common denominator is x power 2 plus 1, minus 1 times x power 2 plus 1 is x power 2 plus 1 equal to 2x power 2 minus x power 2 minus 1 over x power 2 plus 1 equal to 2x power 2 minus x power 2, x power 2 minus 1 over x power 2 plus 1. Take the limit of this function when x approach to negative or positive infinity, then the answer will be, since the degree of the numerator and denominator are equal, the coefficient of the leading term in the numerator 1 and of the denominator is also 1, so the answer is 1. The equation of the horizontal asymptote is y equal 1. Choice C. Question number 58. If f of x equal ax plus 3 over b minus 2x has horizontal asymptote at y equal negative 2 and vertical asymptote at x equal 5 over 2, find the value of 3f of a plus 5f prime of b. To find the value of this term, we need to find the value of a and b. Since the function has vertical asymptote at x equal 5 over 2, then to find the vertical asymptote, we write the denominator equals 0, b minus 2x equals 0. The value of x is 2x equal b, then x equal b over 2 equal to 5 over 2, the vertical asymptote of this function. Then b over 2 equal 5 over 2, it means that b equal 5. To find the value of a, we have that the given y equal negative 2 is a horizontal asymptote. Then the limit of this function when x approach to positive or negative infinity is ax plus 3 over b minus 2x equal to, since the degree of the numerator and denominator are equal and the coefficient of the leading term in the numerator is a and the coefficient of the leading term in the denominator is -2, then the answer is a over -2 equal -2, the equation of the horizontal asymptote. Then a equal -2 times -2, 4. We find the value of a and the value of b. Substitute this value in the function, then f of x will be ax plus 3, it means 4x plus 3 over b, 5 minus 2x. This is our function. Then find the derivative of this function. Since we want to find f prime of b, the derivative of this function equal to the denominator 5 minus 2x times the derivative of the numerator 4 minus the numerator 4x plus 3 times the derivative of the denominator -2 over denominator square 5 minus 2x square equal to, open this brackets, 4 times 5, 20, 4 times -2x, -8x, negative times negative, plus 2 times 4x, 8x, 2 times 3, 6, over 5 minus 2x all power 2. Reduce negative 8x with positive ax, add 20 to 6, 26 over 5 minus 2x power 2. Now, 3 times f of a, it means f of 4, since a equal to 4, then f of 4 is, rewrite it here, 4 times 4, 16, plus 3 over 5 minus 2 times 4, 8. Then the answer is 19 over -3. 3 times negative 19 over 3 plus 5 times f prime of b, it means f prime of 5, 26. Substitute every x with 5. 5 minus 2 times 5, 10, all power 2 equal to 26 over 5 minus 10, -5 over 2, 25. Then 26 over 20, 25 over, 26 over 25 equal to, reduce 3 with 3, -19, plus reduce 5 with 25, 26 over 5 equal to, common denominator 5, 5 times -19, -95 plus 26 equal to 5, -25 plus 26 is -69. Choice A. Question number 59. Which is horizontal asymptote of the function f of x equal 1 minus absolute value x over x plus 2? Find the limit when x approaches to positive and negative infinity for this function 1 minus absolute value x over x plus 2. Now, when x approaches to positive infinity, the absolute value equal to x, absolute value of x equal to x, then the limit x approach to positive infinity will be 1 minus x over x plus 2. Since the degree of the numerator and denominator are equal, then the answer is the coefficient of the numerator of the leading term over the coefficient of the leading term on the denominator equal to -1. When x approach to negative infinity, then absolute value of x is equal to -x 1 minus minus x is 1 plus x over x plus 2. And the answer is the coefficient of the x in the numerator 1 over the coefficient of x in the denominator is also 1. Then we have two horizontal asymptote for this function, negative 1 and 1. And in our choices, we have y equal 1. Therefore, the right choice is A. The set of questions, page number 160 in the book of the ministerial question. Question number 1, find the equation of the slant asymptote of the graph of the function f of x equal to x power 2 over x plus 1. As you know, the function has a slant, the rational function has a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator, and there is no common factor between the numerator and denominator. Now, to find the slant asymptote, divide 2x power 2, divide x plus 1. 2x power 2 divide x is 2x. 2x times x is 2x power 2. 2x times 1 is 2x. By subtraction, 2x power 2 minus 2x power 2, 0, minus 2x. Minus 2x divide x is negative 2. Now, negative 2 times x, negative 2x, negative 2 times 1, negative 2. By subtraction, change the signs of the terms. Negative 2x plus 2x, 0, to the remainder. Therefore, the slant asymptote is 2x minus 2. Choice A. Question number 2. Find the equation of the slant asymptote of the function 3x power 2 divide 3x power 2 minus 5x plus 3 over 3x minus 2. Take the first term in the numerator, 3x power 2, divide the first term in the denominator, 3x. 3x power 2 divided 3x is x. Now, x times 3x, 3x power 2. X times negative 2, negative 2x. By subtraction, change the signs. Then 3x power 2 minus 3x power 2, 0, minus 5x plus 2x, negative 3x plus 3. Negative 3x divide 3x, negative 1. Negative 1 times 3x, negative 3x, negative 1 times negative 2, 2. Change by subtraction, change the sign of these terms. Negative 3x plus 3x, 0, 3 minus 2, 1, plus 1. Therefore, the equation of the slant asymptote is x minus 1. Choice A. Question number 3. Also find the equation of the slant asymptote of this function. Divide x power 2 minus 2 over x. X power 2 divide x, x. Now x times x, x power 2. Change the sign, 0, minus 2, the remainder, then the slant asymptote is y equal x. Question number 4, find the equation of the slant asymptote. Also, divide 3x power 2 plus 13x plus 10 over x plus 5. 3x power 2 divide x, 3x, 3x times x, 3x power 2, 3x times 5, 15x. Change the sign of these terms. 3x power 2 minus 3x power 2, 0, 13 minus 15, negative 2x plus 10. Negative 2x divide x, negative 2 times x, negative 2x, negative 2 times 5, negative 10. Change the sign of these terms. Negative 2x plus 2x 0, 10 plus 10, 20. Then the answer is 3x minus 2. Choice B. Question number 5. Find the equation of the slant asymptote of the function. Divide 2x power 2 minus 4x over x plus 1. 2x power 2 divide x, 2x, 2x times x, 2x power 2, 2x times 1, 2x. By subtraction, 2x power 2 minus x power 2, 0. Negative 4x minus 2x, negative 6x. Negative 6 divide x, negative. Negative 6x divides x, negative 6. Negative 6 times x, negative 6x. Negative 6 times 1, negative 6. By subtraction, negative 6x minus 6x 0. Then the slant asymptote, the equation of the slant asymptote is 2x minus 6. Choice D. Question number 6. Find the equation of the slant asymptote for this function. Divide x power 2 plus 1 over x. X power 2 divide x, x. X times x, x power 2. By subtraction, 0 plus 1. The remainder is 1 and the answer is y equal x. Choice C. Question number 7. Find the equation of the slant asymptote for this function. Divide negative 2x power 2 minus x plus 1 over x minus 1. Negative 2x power 2 divide x, negative 2x. Negative 2x times x, negative 2x power 2, negative 2x times negative 1, plus 2x. By subtraction, negative x minus 2x, negative 3x, plus 1. Negative 3x divide x, negative 3. Now negative 3 times x, negative 3x, negative 3 times negative 1, plus 3. By subtraction, plus 1 minus 3 minus 2. The remainder and the result is negative 2x minus 3. Choice A. Question number 8. Find the equation of the slant asymptote for this function. Rewrite 8 minus 5x minus 2x power 2 as negative 2x power 2 minus 5x plus 8. Divide x plus 3. Negative 2x power 2 divide x, negative 2x. Negative 2x times x, negative 2x power 2, negative 2x times 3, negative 6x. By subtraction, negative 2x power 2 plus 2x power 2, 0, minus 5x plus 6x, x plus 8. X divide x, 1, 1 times 1, x, 1 times 3, 3. By subtraction, the result is negative 2x plus 1, and the remainder is 5. And the answer is C, 1 minus 2x. Question number 9. Which equation has no slant asymptote? The first, we know that we have two conditions for the function to have a slant asymptote. The first condition is the degree of the numerator is 1 more than the degree of the denominator. The second condition is that the numerator and denominator has no common factor. As you see, choice A, the degree of the numerator is 3 and the degree of the denominator is 1. Therefore, this function has no slant asymptote, since the degree of the numerator is 2 more than the degree of the denominator. But for the other three choices, the degree of the numerator is 1 more than the degree of the denominator. Then the right choice is A. Question number 10. Which function has vertical asymptote at x equals 3 and slant asymptote at y equals 3x minus 2? The denominator is x minus 3, since the function has a vertical asymptote at x equals 3, and we can find the numerator by multiplying the denominator of the function by the slant asymptote of this function plus the remainder. It could be any point. Now, x times 3x, 3x power 2, x times negative 2, negative 2x, negative 3 times 3x, negative 9x, negative 2 times negative 3 plus 6 plus the remainder, any number. Then the result will be 3x power 2 minus 11x plus any number. Let us write it A. Then the function will be 3x power 2 minus 11x plus A over x minus 3. Then the right choice is A, since we have the first two terms in the function 3x power 2 minus 11x. Question number 11. Which function has a vertical asymptote at x equal 1 and slant asymptote at y equal negative 2x minus 3? Since the function has a vertical asymptote at x equal 1, then the denominator is x minus 1. Now, for the numerator, multiply x minus 1 by the slant asymptote of the function, negative 2x minus 3, plus the remainder, equal to x times negative 2x, negative 2x power 2, x times negative 3, negative 3x, negative 1 times negative 2x plus 2x, negative 1 times negative 3 plus 3 plus the remainder, equal to negative 2x power 2, negative 3x plus 2x, negative x plus a. Therefore, the function is negative 2x power 2 minus x plus a over x minus 1. The right choice is B, and the value of a is 1. Question number 12. Which function has vertical asymptote at x equal 1? Then the denominator is x minus 1 and slant asymptote at y equal 2x. Then the numerator of the function will be multiply the denominator x minus 1 by the slant asymptote plus the remainder, equal to 2x times x, 2x power 2, 2x times negative 1, negative 2x plus the remainder, a. The function will be 2x power 2 minus 2x plus a over x minus 1. Choice B. Question number 13. Find the equation of the slant asymptote of the function f of x equals 6x power 2 plus x plus 3 over 3x plus 2. Divide 6x power 2 plus x plus 3 by 3x plus 2. 6x power 2 divide 3x, 2x, 2x times 3x, 6x power 2, 2x times 2, 4x by subtraction, 6x power 2 minus 6x power 2, 0, 1 minus 4, negative 3x plus 3. Negative 3x divide 3x, negative 1. Negative 1 times 3x, negative 3x. Negative 1 times 2, negative 2. By subtraction, the remainder will be 6 and the answer is 2x minus 1. Choice C. Which function has vertical asymptote at x equal 2 and slant asymptote at y equal 2x plus 5? Since the function has vertical asymptote at x equal 2, then the denominator is x minus 2. For the numerator, multiply the denominator x minus 2 by the slant asymptote 2x plus 5, add to remainder. X times 2x, 2x power 2, x times 5, 5x. Negative 2 times 2x, negative 4x. Negative 2 times 5, negative 10 plus remainder. 2x power 2, 5x minus 4x, x plus the remainder, a. Then the result is 2x power 2 plus x plus a over x power 2. Then the right choice is a. And the value of a is 3. Question number 11, 15. Which function has a vertical asymptote at x equal 1 half and slant asymptote at x equal y equal 3x plus 2? Since the function has a vertical asymptote at x equal 1 half, we can rewrite it by multiply both sides by 2. 2x equal 1, then 2x minus 1 is in the denominator. And for the numerator, we can multiply the denominator 2x minus 1 by the slant asymptote 3x plus 2, adding to the remainder. 2x times 3x, 6x power 2. 2x times 2, 4x. Negative 1 times 3x, negative 3x. Negative 1 times 2, negative 2 plus remainder. 6x power 2 plus x plus a. 6x power 2 plus x plus a is the function, and the right choice is none. Since here we have 6x power 2 minus x, but the function is plus x, and the other function are wrong. Therefore, the right choice is none. See you next lesson.